The CRT, short for cathode ray tube, produces the images that we see on our TVs and computer monitors, the ones that aren't LCD or plasma, that is. Believe it or not, the cathode ray tube was invented back in 1879. A CRT is made up of two main components, a large glass bulb and an electron gun. CRTs start with a molded glass bulb. First, workers remove microscopic debris using a high-pressure water rinse. Then spray hydrofluoric acid to clean the glass at an atomic level. They pour a phosphor solution into the bulb. Phosphor is an organic compound that emits light when struck by electrons. The phosphor particles settle and form a chemical bond with the bulb face. Workers pour off the excess solution and clamp the bulb over a nozzle that sprays clear lacquer. The centrifugal force guarantees an even coat over the phosphor to protect it for the next step. He paints a conductive coating over the anode button, which will provide a flow path for the electrons that'll light up the phosphor particles. Next, a worker drops an aluminum pellet into a tungsten coil. He places the bulb over a vacuum device and draws out the air. Then he applies an electrical current to the coil. It evaporates the aluminum pellet, which spreads a mirror-like coating on the inside of the bulb. Now they heat the bulb to 218 degrees Celsius for 1 hour. This bakes out the lacquer and any trace of moisture. Using a high-temperature flame, a worker aligns and fuses a glass neck to the bulb. Then he paints it with the same conductive coating. This assembly is part of the electron gun that goes inside the bulb. It shoots electrons at the bulb's phosphor particles. That lights them up, creating the images we see on screen. Workers stack the grid cups that focus the electrons on the screen. Then, using beading glass, align and fuse them into position. Robots heat and affix the beading glass to assemble the electron gun components. They cool off the gun with pressurized air. Once cool, a worker builds up the gun and inserts the completed gun assembly into the bulb. Next, he positions the bulb on a glass-blowing lathe and cuts excess glass from the neck. Using a graphite paddle and a high-temperature torch, he mates the glass neck to the electron gun's stem. This ceramic heating coil melts that green glass pellet to keep the bulb under vacuum. The tube is heated to 400 degrees Celsius for 2 hours, and once again, a vacuum is drawn. To minimize image flicker over the tube's lifespan, workers condition the bulb using a high-voltage coil. It smooths any rough surfaces that might remain on the electron gun. Finally, workers apply electrical connections to the electron gun to bring the cathode ray tube to life.